All right, hi. Ms. Ballio and I are going to show you the chemical reaction lab today. And what we're going to do is we're going to be taking some hydrochloric acid and we're going to be mixing it with some zinc, and it will produce a reaction. It will create a gas that we're going to capture in some balloons. So the first thing that I had to do is I had to take this electronic balance and I had to find the mass of 5 grams of zinc. So that's what's in these little weigh dishes. And then I took some different size graduated cylinders because I needed different amounts of hydrochloric acid. So over here is 2 milliliters, this is 15 milliliters, this is 50 milliliters, this is 75 milliliters, and over here we have 100 milliliters. So what I'm going to do is I'm going to put the hydrochloric acid into each of these Erlenmeyer flasks and then add the zinc and then put the balloon over the top so we can capture the gas. So start down here with the 2. I'm going to put that in there. It's not very much, as you can see. The 15 is a little bit more. This is the 50. This is 75 milliliters. And this is the 100. So Ms. Ballio and I just put the zinc into each of the balloons. So each balloon has 5 grams of zinc. And then what we're going to do is we're going to put the balloon over top of the mouth of the Erlenmeyer flask. We are going to find the mass of each Erlenmeyer flask, and we'll record that data for you. And then we are going to show you dumping the zinc from the balloon into the hydrochloric acid, because we want all of this to stay in a closed system so that none of the gas can escape, and we're capturing all of the gas into the balloon.
Go.
So we just found the mass of all of this together, and what I'm going to do is I'm going to take the zinc and I am going to just shake it all down into the zinc, give it a little stir, and then it's going to start reacting. And then I'm going to do this with the 15 milliliters. And it'll start reacting. This is the 50. And it's starting to bubble. And then this is the 75. And then this is the 100. And all I did was just shake the zinc into the hydrochloric acid. And as you can see, the balloons are starting to inflate. And we're going to let this reaction go for a little while. And then
Oh, the pink one's
the pink
not doing
one is
so
not,
good.
it's not doing so well.
Oh!
Oh, there was more pink in the orange. I thought I'd gotten it all.
See if the pink will go.
And
It's going!
slowly. And if you could see in the Erlenmeyer flasks there, you can see the gas rising up into the balloons, and there's a lot of bubbling, and they're a little bit warm, not as warm as the magnesium was. But we're going to let this go for a little while and capture as much gas until the reaction stops. So we've allowed the zinc and the hydrochloric acid to react together for about 30 minutes. And this is the formula. So we took zinc, which was the solid, the metal. We mixed it with the liquid, which was the hydrochloric acid. And it reacted, and I'm going to show you in a second that it produced something called zinc chloride. And then it's also produced hydrogen gas, which is what we've captured in the balloons. So if we look down here, the one that had 2 milliliters of hydrochloric acid. You can see that the zinc, hopefully, is now like black and flaky, and that the balloon is kind of small because there wasn't a lot of hydrochloric acid, and that the zinc actually started this kind of shiny metal. So the black in the flask is the zinc chloride, and up here in the balloon is the hydrogen. And it's true of all of these. A couple of them are still reacting, but this could go on for quite some time. And then you can see the sizes of the balloon. Over here with the pink, this was 2 milliliters of hydrochloric acid. They had the smallest balloon. Then we had 15 milliliters, which was the next biggest. And then 50, 75, and 100 milliliters. The balloons are all about the same size. So what Ms. Balio and I did is we recorded the mass at the beginning of the experiment, and then we just found the mass after the experiment. And we will present you with that data in the lab to show you that the law of conservation of mass says that what you started with is what you should end up with.